in spotlight.
Yep.
Yes. Thank you very much for coming along, everyone. Welcome. It's my pleasure to introduce Jenny Pierson, who works for Australian Wildlife Conservancy, but Jenny's got a background in wildlife genetics, and she's worked locally at ANU and out at Tidbinbilla, and this is her most recent position at AWC, where she's heavily involved in a lot of work around sort of strategic planning for the AWC, around particularly their translocation work and impacts of climate change and how that's going to affect how they approach conservation issues. So it's a pleasure to have you, Jenny. Thanks very much.
Thanks, Richard. Hi, everyone. I'm going to try to avoid this spotlight here. So let me know if I'm backing out of the way too much. But yeah, so today I'm going to be talking about how AWC is trying to scale up their conservation effects. So I'm going to give you a little bit of background about AWC and the biodiversity monitoring program that we do across the country. I wanted to start by acknowledging the traditional owners of the land on which we work. I work down on Yuin country, and I respectfully acknowledge their connection to native wildlife, waters, country, and culture. So Australian Wildlife Conservancy was established in 1991. And it first started with just about 268 hectares over in Krakamaya in Western Australia. And Martin Copley made the first fenced reserve over there. And at this stage, we now work across close to 13 million hectares across the country. We've got 234 employees, and 70% of our staff works on the ground. And so that's something that we really pride ourselves on. And we're primarily privately funded, so mostly through philanthropy. So one of the spaces that we've been really expanding out into in the last few years has been partnerships. And probably about 2 years ago, one of our big partnerships that we entered into was the Northern Australian Pastoral Company. And this is a space where it really represents how we're trying to scale up conservation efforts. And so it's one thing for us to be able to acquire, private wildlife sanctuaries that we own and manage, but our mission and our vision at this point is to really scale up conservation across Australia. And so to do that, we really need to be partnering with people like NAPCO, who are managing large tracts of agricultural land across the country. We're also partnering with more and more traditional owners. And so one of our recent partnerships is Knowledgeu in the Central Desert. So it's at 400,000 hectares that's connected to New Haven, one of our other sanctuaries, which is over 100,000 hectares. So by partnering in this way, we have now areas that are really large tracts of land where we can scale up to make the impact that we're looking to do. And then also we've got a couple partnerships with New South Wales parks. And so we manage both the Pilliga and Mallee Cliffs. So we have fence reserves there, but we also do the conservation land management across all of those national parks. We've just recently entered into a partnership with Queensland government where we're now managing Northern Hairy-nosed Wombat for Richard Underwood Nature Reserve. And primarily what we do is conservation and land management. And so it's a lot of the threat management, threat control across these properties. So with weeds, I believe weeds are now half the plants in Australia. So we spend a lot of time looking at how we can, with the amount of staff that we have over that acreage, you can calculate how few people that is, 234 people, 70% of those on the ground for that many hectares. We have to be very strategic in what we do. So we spend a lot of time right now trying to look at how we can, maximize our efforts in terms of the impact of our weed control. We do a lot of feral herbivore control, and that's both, through management and through fencing. Obviously, we spend a lot of time on foxes and cats. And then in places like the Kimberley, our primary action is actually fire management. And probably a lot of folks, when they think of AWC, think about the fenced reserves. So we do manage more cat and fox-free land than anyone else in Australia. And we have more fenced reserves, and we're also doing these at a scale that's quite large. So most of our fenced reserves now are anywhere between 8,000 and 10,000 hectares. And across the 11 locations, we've got 24 species that we've reintroduced to these sites and 53 populations. And to me, what's really exciting at this stage is when you look at this figure, what you can see is basically, with these color codes, you can see, at New Haven, the species that we have there. And you can see most of them within AWC at this point are even metapopulations. So within our sites, we've got, brush-tailed bettong and bilby across, 6 to 7 sites, burrowing bettong across 4 sites, numbat across 4 sites, phascogales are up to 3 sites. And that's what we're aspiring to do, is to build up metapopulations even within our own estate. And we work really closely with the recovery teams so that other places these species are can be managed, directly in terms of both numbers, but also more importantly, the genetic management of these species over time. So today what I want to talk about is our biodiversity monitoring program. So we have Australia's largest biodiversity monitoring program, and AWC really prides itself on using, a science-based approach to their management. And that's through what we call our Ecohealth program. And Ecohealth, we have our ecological scorecards, which is pretty typical for government and nonprofit programs. We really love, an arrow system, a stoplight system, but it actually really helps to be able to boil things down. In the end, for our conservation decision making, we need to know how things are going, is what we're doing working, and what do we need to do next. So we need a pretty simple system for that. We partner quite a bit with, a large variety of scientific institutions across Australia. We're working on a climate change adaptation strategy to be able to, try to figure out what we can do about both extreme events and changes in the mean climate and those impacts across our sites. And we also look at really targeted research, so trying to identify the knowledge gaps through this program. So that's a lot of what our biodiversity monitoring is helping us do, is figure out what we don't know. And really, how we see it is this model of accountability really helps us in terms of, both our partnerships and enabling better outcomes. And so what we've seen over time is we're getting contracted more and more by defense parks, governments and non-governments to be able to roll out what we do as a standard across all of our sites. And the way this fits in is, we kind of have our inventory. When we first get a site, we do a complete inventory of it. And then we do the monitoring of the threats. And then essentially, our science program just looks through giving advice to implementing conservation land management. So the way AWC works is we actually have two different streams that don't meet into the top. And so we have our science program, which are our ecologists, and we implement translocations, monitoring, research. And then we have a land management program where, that's the people that implement operations on the ground. So they do all of the, feral management, weed management, that sort of stuff. And we work together in terms of giving that advice and reporting. So we don't have the numbers compiled for 2023 yet. We're working on that right now. But in 2022, this is pretty standard for us. We translocated 13 species, had over 280,000 trap nights. So that's live trapping. Have over 1,800 bird surveys and over 480 vegetation surveys. And today I want to talk through a few of the results and how we're working to try to start evaluating these results a little bit better. So we've been monitoring things for a long time, and the space we're really sinking our teeth in now is evaluation of what we've been monitoring. And I'm going to present mostly birds because, again, I think when we think about AWC, a lot of times we think about fenced reserves and we think about cute fuzzy mammals. And we've also got incredibly stunning birds. But we monitor everything, I guess, is the point. So again, that point of the 480 vegetation surveys, that's something that you don't hear a lot about, what we're monitoring, tracking through time. So I'm going to start by chatting a little bit about the impacts we've seen of the fenced reserves on the mallee fowl that we have. And that's at 3 different sites that we've got at Mount Gibson, at Scotia, and Mallee Cliffs, and how mallee fowl are doing both inside and outside our fenced reserves there. And one of the things that, we're really working towards doing more and more in terms of, again, the scaling up conservation efforts is trying to integrate technology as much as we can. So as a small nonprofit, we can be really nimble this way. So we're really interested in trying out new innovative methods. And one of the places we've done that is to use LiDAR to find our mallee fowl mounds. So traditionally, people have tracked them and found them on the ground, and we had, ones that we knew where they were, that we were monitoring over time. And a few years ago, we entered into research where we were looking at how well we can find our mallee fowl mounds with LiDAR. And it turns out, because of, the way they look and the way LiDAR works, it's an incredibly useful approach to find them. So now what we do across all of our sites is we use LiDAR regularly to find our mallee fowl mounds. And that creates that baseline for us to be able to monitor which mounds are active and which ones are not active. And what we see when we go to Scotia is we can see, basically looking at the percent of mounds inside and outside the fence. So if you look at the mounds that are surveyed versus not surveyed, and then we compare which ones are active that year versus not active that year. And consistently at Scotia, what we've seen is that inside the fence, we have a lot more active mounds than we have outside the fence. When we look at Mallee Cliffs, we see a similar pattern. So Mallee Cliffs has only been fenced and predator-free for a few years. And so we have the same pattern there where we have generally more active mounds inside the fence versus outside the fence. What we looked at next at Mallee Cliffs was also the pattern of what we see with those active mounds and rainfall. So this was looking across all of the mounds that we monitor versus inside and outside the fence, because we had a longer data set for that. And what we can see here is we see a pretty strong relationship between rainfall and the amount of active mounds as well. So the more rainfall you have, the more activity you have in your mounds, they do well. So we're able to put that together at Mount Gibson, where we've had a fenced area going that's been predator-free since about 2015. So with those data sets, we looked at both the proportion of mounds that were active inside and outside the fence, and looking at that in the context of rainfall as well. And what we see here is that basically when things are going well, so when there's a lot of rainfall, we have a pretty similar pattern inside and outside the fence. We had drought between 2017 and about 19 there, and we saw inside the fence, they did a lot better than outside the fence when we had what we'd consider a regular drought there. And then when they recovered from the drought, they all did really well. So again, when there was plenty of rainfall, the fence didn't really help that much. They were doing really well outside the fence as well. Now, Mount Gibson, I wish I had the numbers to be able to summarize and tell you, we experienced an incredible hot drought at Mount Gibson this year. I was actually out there last November, and we were having multiple 40-degree days, not allowed to drive on the roads already in November. And we had huge declines in a large number of our species that were at that site. And what we saw is that when we had a severe combination of heat waves and drought, we had absolutely no activity anywhere for valleyfowl. So again, when you have these extreme events, it's, nothing we did could have helped the valleyfowl in that scenario. And that really is probably one of our biggest challenges moving forward, is these extreme events. When you have that, what can we do to provide some resilience that our normal threat management isn't able to do? So for the rest of the talk, I'm going to talk about what I like to call the other 98%. So this is just a bit of a reminder of only 2% of AWC lands are in these fenced reserves. 98% of the land that we manage across the country is actually outside of the fenced reserves and the majority of what we're doing. So I'm going to spend a little bit of time talking about Barra Wildlife Sanctuary, where we do a little variety of the ways we monitor birds and a little bit of a comparison of the different methods there. So we've been managing Barra since about 2010. It's one of our medium-sized reserves at about 14,000 hectares. In that area, it's got quite a diverse range of habitats. And quite a few species, and a lot of species that are kind of on the edge of the ranges there. So it's a really popular place for birders to go and holiday and camp there. And that helps in terms of our citizen science that we do there. So for a long time now, we've been doing 3 different methods there in terms of monitoring the birds. We do daily bird lists, we do fixed route surveys, and we do an annual bird banding. And all of this work is in collaboration with both Birds Queensland and the Queensland Bird Research and Banding Group. And I have to give a lot of credit to Helena Stokes, who's the sanctuary ecologist out at Barra, who's the one who's really summarized all this work for us today. So the daily bird list is essentially, the campground host. We have a campground host where everyone stays every night. Everyone gathers there, and at the end of every day, because again, this is a really, bird tourist place to go. People basically, give their list of what they saw that day and the maximum group size. And we record that information to get trends in terms of what people are seeing at the big level. And we can get things like species richness, daily occurrence, and mean maximum group size. So basically, we take if someone saw 10 and someone saw 20, we record 20 of that species for that day. We've got our fixed route surveys. This is the method, this is our standard bird method we use across all of our sanctuaries. So it's your standard, 2 hectare, 20-minute surveys designed by BirdLife however long ago. And this is done on a fixed route where in between we also take incidental observations for our overall species richness that we report. And for this, we get what we call a reporting rate. And our standard reporting rate is what we use for an abundance index across all of our sites. And with that, we can also look at both habitat associations and environmental associations with that reporting rate or abundance index. And finally, with the annual bird banding, this is an opportunity to get a lot richer data than you can with something like a reporting rate. So it's a much more intensive method, but with that, we get a different type of abundance index, but we also get a little bit of demographic information, which can be quite valuable. So for things like, proportion of juveniles can tell us a little bit about what recruitment might be happening in the population. And something like body weight also tells us a little bit about, something around fitness of the species and how they're doing there. And so what we want to do is compare these 3 things and see, for the different levels of effort, one's like, the campground, you just have to ask everybody, what did you see? What did you find? Versus the intensity, bird banding the skill level, the organization, all that kind of stuff that happens there. So generally, you can see, the kind of information we can get with the daily bird list. You can see similar patterns across the species. Here you can see, pink cockatoo. If you want to see a pink cockatoo, head to Barra is what this says. And even for things like the Bork's parrot and the Hall's babbler. So I think this is a site where I think all three babblers are seen all the time. So it's quite a special site in terms of the babblers. But it's interesting in terms of you can see at least the same general patterns in terms of when you're seeing the species and when you're not tending to see the species as much. And overall, this gives us, at the very highest level in our program, we try to report how many species out of, what are known do we see there. So it's pretty coarse data, but we can see, the number of species out of, we know there's over 200 and some that exist at Barra. When we get to the fixed route surveys, we can look at things a little bit more in depth. And so what we can do there is try to see which kind of environmental variables the trends in the species might be associated with. And so, for instance, something like the spotted bowerbird, we can see the reporting rate is associated with the annual rainfall, whereas the striped honeyeater, the reporting rate is more associated with the previous year's rainfall. So we can look at all these species and see which of these different environmental variables have the tightest ecological relationship, and that helps inform us in terms of what we might expect for the species. So there's less data for this in terms of, we don't have the hundreds of species with the daily bird calls. But because we have the repeated measures over those fixed surveys, we do get quite a bit of data in this method as well. And then finally, for the bird banding, what we can look at is first is kind of, capture rate. And again, just looking at the general pattern for this of, the annual rainfall compared to capture rate, we can see generally, we see, a match between the capture rate and the annual rainfall. But the big difference here again is the demographic information. So when we can look at something like, the proportion of juveniles that we're catching, we can look at, what kind of recruitment are we getting in those years compared to the rainfall. So I'm just going to go through two different species and show you the three different methods for those two different species and the different kind of information that we've gotten for those different methods. So again, that really coarse kind of daily bird call for something like the zebrafinch, if you remember the rainfall graph, this kind of matches it really well. And it kind of goes along the group size. So something like the zebrafinch is in these really big groups when things are going well. So when you have a lot of rainfall, if you look at the, the axis of this graph over here, you get these really big groups. And that also seems to be, matching with, when you see them. So you don't see them very often when the group sizes aren't that big. When we look at the bird banding, we see something really similar. So when we had lower rainfall, we weren't really catching any. When there's a ton around and big groups around, we're catching lots of them. And body mass was a bit, a bit all over the shop. We saw a little bit lower body mass in 2016, but in lower years, we still saw a higher body mass. So we didn't gain a lot from that. But interestingly, with our fixed route surveys, in terms of the relationship with annual rainfall, what we saw there is essentially, if you're looking at something as simple as probability of occurrence, all you need is a little bit of rainfall and there occur. You don't really capture anything greater than that in terms of the variation in the group size, how many might be out there, how frequent you'll see them. Basically, they will occur at a site if you have a little bit of rainfall. So we're not really gaining a lot from that fixed route survey in terms of telling us something about probability of occurrence there. The white plume honeyeater has a really different pattern when we look at these types of things. What we can see here is that essentially we see them all the time. And that the mean group size, again, that axis is much lower, so they don't travel in those big groups, so you don't get that same kind of impact in terms of those flocks traveling around. Essentially just varies between about 4 and 12. And so here we see a really different pattern in terms of that capture rate and the mean adult body mass. We see a much tighter relationship in terms of that pattern with rainfall and how that seems to impact the fitness of these birds. They do seem to track and do better when there's more rainfall in the landscape. And again, that matches the fixed route surveys where we do see a much tighter relationship in terms of the previous year's rainfall in particular and the abundant index that we see. So it's not a huge increase, but a significant increase. So next, we're going to pop up to Mornington in the Kimberley and talk a little bit about some targeted surveys that we do. So we have general surveys that we do. So for most of our sites, we do the standard 2-hectare surveys. And then at most of our sites, we have species that are either what we consider iconic species or threatened species, and we will do targeted surveys for these. So one of the examples we have for that is the Gouldian finch. And for that one, this is a really tricky species because basically we monitor them at water courses. So we have a standardized approach, and we have, we go out for 5 mornings to 5 different water courses. And what we find is this incredible variable pattern of how many Gouldian finches we record in the landscape. And one of the things that we've identified with this data set, and one of the things that we're working on revising right now, is the fact that, essentially we have a real bias in this, because when there's less water in the landscape, they're more concentrated at the few water courses. So there's not necessarily more Gouldian finches out there. It could actually be, the reverse situation where there's less water, there's less Gouldian finches, but they're all at the one place where we're monitoring. Whereas when there's heaps of water in the landscape, we're probably recording fewer, but they might actually be doing better. So the place that we're working in now is essentially trying to figure this out. We've got all these trends. We've been monitoring, doing this monitoring across all of our sites for a long time now. What we want to do is be able to evaluate that and say, is that a worrying trend? Are things doing poorly? Or in some cases, are they doing well? Is what we're doing working well? Or is it just an innocuous fluctuation? Is it, a bias from sampling? Is it weather associated? And that's probably the biggest trend that we're seeing is, most things are really rainfall driven. And so Holly Sitters, the rest of the talk really have to attribute to Holly. Holly's on the national science team, and she's now sinking her teeth into all these data sets, trying to figure out a better way for AWC to evaluate the data that we have in our monitoring program. And so she's really, trying to identify a method that's detecting what we would consider important decreases. And, basically insensitive to transient changes and suitable for short time series and long time series. So one of the challenges is, getting these data sets that are long enough. And particularly when we're trying to really focus in on targeted surveys when possible. So for our surveillance monitoring, we may do that every couple of years. So then you're looking at, to get 10 data points, it might be 20, 30 years. And we want to have something that we can use as fast as possible. And really importantly, be straightforward to implement. So now we're going to jump over to Buckaringa. So Buckaringa is a fantastic little sanctuary. It's only about 2,000 hectares, but conserves really important habitat in the southern Flinders Ranges and things like yellow-footed rock wallaby populations. And we have to really thank Keith Bell-Chambers for this. So Keith is one of those, ecologists who's been on the ground there for ages and ages, is incredibly knowledgeable and committed to this. And essentially, the place that we started is looking at, basically trying to answer the first question is abundance driven by rainfall? If it is, then basically calculate that relationship with rainfall and see if what we're observing is essentially mostly rainfall driven or if it's outside that. And then if it's not driven by rainfall, the first thing we're doing is identifying just a reference period then for the first part of the data set and saying, is it inside and outside of that, as we start to look into the other things that might be driving that abundance. So first we can just look at, here's the pattern of rainfall at Buckaringa, generally about 300 millimeters a year. So not, an incredibly wet place or incredibly, somewhat semi-arid. And a few years where we do have, relatively low rainfall. So first we can see, some birds are, doing really well in this instance. So the first thing Holly's done is basically, calculate the relationship between, the bird and rainfall. And we can see, something like the singing honeyeater has a real peak in that mid-rainfall. More rainfall isn't always better. More rainfall actually declines than the lower. And then calculate essentially, here you can see the blue dots are what we would predict based on that predictive relationship with rainfall. And the black is what we're actually seeing. So if it's within what we see for the blue, we can say it's within our baseline. And then we also assign a confidence to that based on the data set. So for the singing honeyeater, we say, yep, it's within the baseline of what we would expect with adequate confidence, nothing out of the ordinary there. Next, we look at something like the southern whiteface. This one is one where there was no relationship with rainfall. So for now, we're using the reference baseline, and that's calculated from the first few years of data. And essentially here we can say, okay, well, it's above the baseline and we have an adequate confidence in that. It's not high confidence because it's just the reference. And again, similar for the willy wagtail, we have the baseline there and we can see that, and this is again, the importance with the willy wagtails of these long-term data sets. We can see for a few years there, we were thinking, oh, what's going on with willy wagtails? And now all of a sudden the last year, we've had a bounce back of the willy wagtails. So we don't know what's driving this. But now we can say, okay, they're above the baseline again. So temporarily, you don't have to worry, but this is a place where we were quite concerned about, what could be happening with woolly wagtails there. And then here we've got the same thing with the purple-backed fairy wren. So at this stage, we haven't seen the bounce back with the purple-backed fairy wren. So with this is a bird that we've said, nope, not detected. So this is, would be a species of concern outside of the baseline. So I'm going to spend a few minutes now moving outside of birds. So back up to Mornington and tell you a little bit about the standard live trapping survey that we do at all of our sites. So for our surveillance monitoring, as we call it, so not targeting key threatened or iconic species, but just general trapping with pitfall traps and Elliott traps to see what's going on. And essentially, again, I wanted to take a minute to kind of just show the amount of effort that goes into this. So we have in Mornington alone, 60 to 100 sites. And at each of these sites, this is the standard that we set up. So we have a grid, usually we have a cage trap on the corners, we have Elliott traps along the line, and then funnel traps and pit traps in here. And you can see even in these landscapes, we go out and dig in the buckets, put in the drift fences. And in the Kimberley, even a lot of the sites are helicopter access only. So it's an incredible effort for us to go out and do this kind of monitoring. And it's all these guys on the ground who are actually doing it. And essentially what we see in the Kimberley is that the reptiles are doing pretty well. So this is for the robust skink. We can see, rainfall in January to July the previous year is what was really driving that relationship. And we can see here that, we consider it within baseline because those error bars are overlapping. So the points, definitely higher, but we still consider that just baseline, not above. And again, for the Bino-nosed gecko, hopefully that said right. That's again one where we see rainfall in that previous January to July, a different relationship again. And we can see that this one is well above the baseline of what we would predict based on that. But the mammals have a really different story. So the mammals that we see in the Kimberley haven't recovered since the last drought. So the western chestnut mouse, again, has a real peak in terms of when we would expect the highest abundance at a high rainfall, but not too high rainfall. And we can see here, since about, I guess, 2019, it's been below, but there were, the predicted values were quite low, and we would have expected with that rainfall for a bounce back, and that's what we have not detected is that bounce back yet. And that's the same for the pale field rat. So again, we have this, peak around 1,200 of where we would see the highest abundance expected for this species. And again, down in 2019, we still would have predicted a pretty low value, but we would have predicted that we would have seen a bounce back based on the rainfall that we saw, and we have not seen that bounce back for this species. So those are species that we have, flagged as being outside the baseline, but again, driven by this thing. So one of the things that's really challenging for us again is, looking at these extreme weather events. So the Kimberley is a place where we had both extreme rainfall and drought in the past couple of years, and we've seen that at a number of our sites. And so when we're getting these big extremes, one of our primary questions is around how can our land management do a better job of improving resilience? And so one of the places that climate change action talks about is when you do threat management, that will inherently improve the resilience of a landscape. But at a certain point, it's not enough. And that's probably one of our target places of trying to understand and learn a little bit more about is when you have the really extreme events, what can be done to try to sustain species? Because in a lot of cases, I think events are more extreme than they used to be, but we also don't have the same kind of source sink dynamics that we historically would have had for things to recolonize. So we don't have the luxury we used to have in terms of some of these bus dynamics in these systems. So just wanted to finish by touching on two projects that we're working on right now in terms of what we consider our innovative biodiversity monitoring. So we're really, again, trying to embrace technology to do a better job. One of those places is using AI to process camera images. And like with what you can get from cameras nowadays, it's incredible that everyone isn't using AI. And so one of the things we're working on, this is a big partnership with all sorts of different people. We've been given a grant to kind of roll out the AI that we've been developing for the last 3 years and really scale that up. So this is the pipeline that we're using. We've got 44 species that we've already created the AI recognizers for, and our goal is, I believe, around 122. And so with that, we've got an incredible resource of camera tap data for an incredible variety of species. and basically using that as training data to initiate the AI model and validate the AI model. And then once that happens, creating an open source AI recognizer and putting that through a pipeline to create the biodiversity metrics and reporting metrics. So that's an ongoing project that we have for the next 2 to 3 years. And like I said, we've got, all these, the source of camera images that we have to train this model is really diverse, working with these different people. So we hope to be able to upscale that to make that a little bit more useful. And then the other space that we're really working on quite a bit is eDNA, and how we can make eDNA something that provides us information that is informative for what we're looking for. So one of the places, we've got a few different projects on this right now. We just had a student finish a project in Krakamaya actually looking at spider webs with eDNA. And we've just rolled out a comparison at our newest site in Barrington Tops Gordon Forest, where as part of that inventory, we do a standard camera and acoustic monitoring grid. And at those sites, we partnered with the University of Queensland, and we put airborne eDNA filters out at all of those same sites. And so that's being processed now. We'll get a direct comparison of what we detected with all 3 of those different methods at the same site to try to help inform us of what in that inventory when we're looking at presence absence stage. And then down the line, we have a number of projects in the works where we're trying to really see if we can advance what we learned from the eDNA. So right now for us, it seems to be best for informing us about really cryptic species if they're there. But if we can gain more information on anything around relative abundance, how far that's traveling, confidence and presence absence, that sort of stuff is a space that we're working on with quite a few partners. So just to tie it back together, this whole space basically, goes into, like I said, we do this across all of our sites. And we're trying to bring this all together to evaluate, to come back in to basically help our land management. So for AWC, it's really all about trying to help inform the threat management so that we can improve conservation outcomes. And if anybody's interested, we do an Ecohealth report for all of our sites each year. They're on the website, so you can go, this is publicly available. You can go take a look and see what we're doing where and what we're finding. And that's it. Thanks.
Thanks, Jenny. That was awesome.
Yeah.
I'm going to ask the first question because I'm holding the mic. I was just wondering, with the hail field rat data that you showed, I remember seeing some data where you could really clearly see from like the early or mid 2000s onwards through those boom bust cycles, through the surveying, populations kind of contracting to those sand seep areas at the base of escarpments and things like that. And so there was this thinking that maybe those areas act as kind of the refuges through those dry years and then they expand out from that. Do you think with like the recent big flooding events and things like that, those areas are kind of the ones that are being wiped out and maybe that's why there's not a bounce back?
I think that's a really good hypothesis and one of the things that we've been trying to delve into. So the scale of the flooding that happened in Mornington in particular is something that we hadn't had in that historical data set before. And so I think that is one of the big questions is, did that change things in a way? And is it just delayed? And so, that bounce back that I showed is, the model saying, oh, in a year, everything should be right. But with that scale of flooding, maybe, so we actually don't know if that's an environmental effect of the species is still there, but hasn't grown enough to be detected. Or if potentially with that flooding, did you actually wipe out some of those little populations? It's interesting, the reptiles are still there. And so you would think, they would have the same type of refuge available. So, but we don't know the answer to that. Yeah.
Anyone else have any questions?
And I think I apologize in advance for this being a question about the business model, perhaps rather than the science.
Yep.
The pragmatist in me says this is really awesome and it's fantastic to see NGOs getting involved in this sort of scale of research. I guess the pessimist in me says, well, isn't this the job of government? And what happens if the NGOs suddenly don't have the cash anymore? So what happens if you can't get money from donors? How do your operations scale in response to that as a driver?
I'll do my best to answer this question. I know a little bit about it. And I think what's really interesting, I think it's a great question. I think it's a question that we, get asked somewhat frequently. And what's really interesting is how frequently we're getting contracted by government to do this across their sites. And I think having worked for government as well, one of the really interesting things is, with an NGO, how nimble we are and how specialized we are at this. And so I think that's a cost advantage. On the business model side of things, what I can tell you is our board is very financially based. And so and our business model is around having things in trust to where we have safeguarded that, and our budget is only around what we have to, so we have we only have 2 ecologists on the board. Everyone else is in the finance sector. And I think that's on purpose in that way because they have safeguarded us in that way. So we have a whole financial report on the web as well that details this probably better for you. But there has been a lot of time spent making sure that we have done things in that financial way to safeguard us, and we only spend what we have to spend that year, which makes it really tight in terms of doing a lot of these kind of surveys, and is a real challenge. Extreme events, again, in terms of, when we have loss of infrastructure due to floods, that's something that really, is challenging for us to evaluate how to move forward in terms of what to rebuild and that sort of stuff. Does that answer your question?
Yeah, thank you so much.
Yeah.
Sorry, just to Jim, and I'll come back to you.
Thank you. That was really good. Thanks very much. Early on, you showed the map of Australia and the variety of reserves, which you sort of the predator-free fenced reserves. How many of those are also free of introduced mammals, introduced herbivores, mammalian herbivores, like everything from rabbits up to camels?
A lot of our fenced reserves, so for the fenced reserves, they're all free of foxes and cats. And I would say a portion of them are free of rabbits. Some of the fenced reserves do have rabbits. And so one of the things that we've done is essentially a cost evaluation there. So in some places, rabbits aren't as common and don't have as much of an impact. And in those places, we have not spent as much of our energy and effort eradicating them. And other places where the rabbits are causing what we have, deemed a significant impact, then we spend time eradicating them. And so field herbivores are completely eradicated inside the fences. Outside the fence is probably where we do more of our field herbivore work. And we have Wongalara is a place up in I want to say North Queensland, but it could be in NT. This is where my depth of knowledge shows. But essentially Wongalara is, I think, the only place where we have a feral herbivore fence. And that's one where we, I think, have a project right now really trying to shore that up. So we have a lot of trouble. It's much harder to keep feral herbivores out of the fence. They breach the fence quite a bit. So we have a different model in different places, but in terms of eradication of feral herbivores and even mustering cattle in the Kimberley, we have very few places where they're eradicated versus controlled.
Yeah, right. Just a suggestion, it might be handy to be able to show on the map which are also herbivore free, not just predator free.
Well, for the fenced reserves, the rabbit free, you mean? Yeah, that would be a good to show that. Yep, that's a good tip. Yep.
Thanks very much. I, in a sense, want to follow on from Ross's question, but I've probably got 2 questions, actually. One is, you mentioned that some state governments are using your techniques, I understand. But what's happening at a national level? How do you integrate what you're doing into what is being done nationally, which itself is not that well integrated across the federal and state government arenas? And perhaps the second question is, you use the term eco-health, but you only talk about species. Where is the work on landscape and ecosystems?
So I answered the first question was, first question again? Go back to this question.
So the first question was, how do
national,
you,
yeah.
how does your work fit into what is happening nationally across state and federal and indeed other NGOs who own bits of land, which is becoming now an increasingly difficult thing to track? Who's actually responsible for conservation across Australia?
Yep. Oh, that's a bigger question, isn't it?
Well, I know what it
Yeah.
used to be.
Yeah, and I think that's where, I mean, I think private NGOs are playing a bigger and bigger role that way, but the way that we integrate is with individual species, so particularly the translocation space, any threatened species that we work on, is through recovery teams. So, anybody who's dealt with recovery teams know that they vary wildly in terms of how functional they are, but that's, the best format that we have. We also have individual, we have a person on the national science team whose role is to, regularly liaise with all the different governments. And so we directly liaise with each state and territory government on a regular basis about all the different things that we're working on. And, from a government perspective, that's probably the best that we can do. On the federal level, we interact with the Threatened Species Commissioner, we interact with, the federal government where we can. But it's mostly through the states that the engagement is done and the interaction is done. And that's very frequent and like I said, regular meetings, just talking through monthly what we're doing and what's planned and how we can work with what they're doing. And one of the biggest places that we coordinate privately is there's an organization called ALCA, Australian Land Conservation Alliance, and it's the private land conservation organization. And we're heavily involved in ALCA, and that's a place where all of the private enterprises can come together. And so, for instance, even have a common voice. And so in terms of things like the national biodiversity market, that sort of thing, we can all come together and have an agreed opinion and voice to work together towards what we think should be done. So ALCA is probably the main place that we try to work together. And then in terms of, the second question.
Landscape scale.
Landscape scale. Ecosystems are really difficult, is what I can say. So we're actually working quite a bit right now to define our priority high value ecosystems. So we do the vegetation surveys and we have vegetation mapping. We've done vegetation mapping across all of our sites, and we have botanists. We have 2 botanists that travel around to all the different sites and do that for us. But I think, one of the places that we are looking at both in terms of climate change acquisition and high conservation values is trying to define our higher value ecosystems. And it's, one of the things we do find challenging is which definition of ecosystem do you use? Is it just vegetation type? How do you incorporate from the climate change space? I'm really interested in incorporating landscape features as well, like topographic complexity. And so, we're really working on what the best definition of that is. There's a lot of different ones out there.
Any other questions for Jenny?
Yeah, thanks. Really interesting. I want to ask with the birds, because some particularly strong flying birds like fly hundreds of kilometers and stuff like that. So when you see a particular species has like a bit of a hump in the middle of the range, I mean, that's at that location, but they might just be migrating to the more drier areas during the wetter periods and then moving back. So you might think, oh, gee, there's a big problem here, but do you consider that sort of stuff at all or not?
I'll say it depends. So when we consider it quite a bit when we're prioritizing species in particular. And so when I say like we have, targeted surveys for priority species, and our priority species, one of the things we consider is how much of our land is key to the species conservation. So it'd be that, if it's a bird that flies a lot, is it important breeding grounds, or is it something that's just passing through and has a huge landscape that it's interacting on? So that's probably one of the bigger places that we pay attention to that. And then in terms of interpreting the trends, I think one of the things is that we've identified that's a problem. So particularly, like I said, with the Gouldian finches, we know a lot of what we're tracking when it comes to things like birds is that. So, we're still developing the best way to, we do a lot of wetland management. So particularly things like, feral pigs, we'll spend a lot of time trying to get them out of the wetlands for the birds. And we have not, identified the best way to really get that direct connection. Sometimes you have to assume you're doing good, and so it will do good, and we're tracking, but we are still working on the best way to connect those two and make sure we have a way to interpret what we're doing. Yeah, so prioritization is probably the best way we do that. Is something, red goshawk is a really good example. It's a threatened species. It's not a lot of our places, but it's always flying through, so it's not something that we prioritize a lot of surveys and management for, even though we work with them a lot because it's so small versus, Sharman's rock wallaby. I think we have 80% of their distribution lies on our sites. So it's a high priority. So that's kind of how we deal with that. Yeah.
think we can do one more question and then maybe we'll leave you off the hook, but did you still have one? Or, yep.
I was just wondering with regards to your patterns of abundance and rainfall. I assume you're also monitoring things like weeds and invasive species. Are you able to get at biological interactions or biological trends? So, you know, foxes go up and then all your small mammals go down and that sort of thing as well?
So I was talking to Jim about this earlier. The main place we can see effects so far is just in the fence reserve. So when we eradicate the foxes and cats, you know, we have lots of beyond just the reintroduced species we see in the malleefowl. I talked about, you know, we've got, you know, lots of things that we've looked at in there and see lots of patterns in there. It is really difficult. Right now we monitor, I guess, you know, the indirect impacts of that. So we monitor, you know, what we're doing in the weed space. In the fire space is probably our most advanced. We do really, you know, quantitative fire reports each year where we look at not just what we've treated, but then, you know, the landscape perspective in terms of fire. So now, you know, the distance to the longest unburnt area, all the, you know, a huge suite of things we calculate each year in terms of our fire metrics. But the scale, you know, we manage 4 million hectares in the Kimberley. And so we're not able, we do fire management over a really large area from helicopters mostly. So the scale at which we do our land management is really big compared to the density of data that we have for that monitoring. So right now in that space, we do rely on the fact that, you know, other smaller scale research that shows when you do this kind of fire management, it helps these species, but it's really difficult with the density of data we have to connect those. We aspire to, certainly, but we're just not able to right now. But we do track quite quantitatively the impacts of that management on the landscape features, if that makes sense. Yeah.
Thanks so much, Jenny. Join me in thanking Jenny again for coming out and giving a seminar. Just quickly before everyone leaves, if anyone wants to join us for lunch, we'll be heading out afterwards.